right. I haven't done a video for a while. No real reason. I guess I just been lazy. Um, but I thought I would go through and talk about one of the courses I've been currently teaching the last few years is AP Physics 1, and kind of go through an introduction to it, and then go through different units, maybe basically how I teach the class throughout the year, and my range of topics, and some of the stuff that I go through. So my first question, I think people have to understand what is physics, and what I see it as is a study how stuff moves. That stuff could be a baseball, it could be a car, it could be heat, it could be a wave, a sound wave, a light wave, it could be an electric charge. If it moves to me. If something moves, it moves because of physics. And so what we find ourselves doing is predicting what's going to happen. We either do that quantitatively with calculations and numbers and formulas, and how long is the ball going to be in the air, how long does it take for the car to go some distance with some acceleration, or we do that qualitatively, which is just simply with words explaining based on the physics principles what's going to happen. What I have found out is that physics, even though people want to make it really hard, physics is actually a lot of common sense. If you push something, it moves. And so we just have to put the proper terms to it. The biggest problem that I've seen is that kids want to make it harder than it is. They overcomplicate the problems. If you don't overcomplicate, you're probably going to do fine. They also, kids are smarter than they give themselves credit for. Because they think physics is hard, they want to make it hard, which is why they overcomplicate it. But they understand more than they think they do. And part of what my goal is just to bring that out from them. So now let's talk about more specifically AP Physics 1. It's algebra-based physics. Now, what that simply means is there's not much math. The math that is involved is simply algebra. You have to be able to do algebra. A lot of kids think they're good in algebra, and just to be honest, they're not. There's not a whole lot of number crunching in AP Physics 1. There is working with expressions, rearranging them. You have to understand variable relationships, whether two variables are linear or inversely proportional. You have to understand that terminology. The idea of linearizing data with a graph and with a lab is very important, which I'll probably talk about that when I talk about the experimental lab procedure, FRQ, which will be later on. That's another topic. I view AP Physics 1 not as problem solving, but problem analysis. You have to explain your answers. There's a big emphasis on that. It's not necessarily plugging and chugging in numbers and getting an answer. It's analyzing qualitatively, and that's a big difference from some of the other physics classes that I've taught. It is not memorization. If you try to memorize everything for Physics 1, it's not going to work. You have to make it through association. And so I tell my kids a lot, associate, don't memorize. They have to understand the relationships, and they have to understand the fundamentals, and I'm going to talk about some of these fundamentals in just a second, like right now. So I consider some of the fundamentals, Newton's laws, his first law. You have to know his laws. You have to understand his laws. I like to express his laws in ways that make it easier to understand, maybe. An unbalanced force causes a change in motion. That's his first law. The second law, acceleration is the net force divided by mass. It's like a mathematical way to express the first law. The third law, a lot of people call it action-reaction. I'm not a big fan of that terminology. No force is alone. Every force has an equal twin, meaning every force has an equal and opposite force. I don't like action-reaction terminology because that implies the two forces don't occur at the same time. They do. Work-energy relationships are also a big fundamental. Work changes energy level. If an energy level changes, work was done. And just simply recognizing that and being able to make that connection is to me pretty critical for Physics 1. Any of the conservation laws, energy, momentum, angular momentum, charge, a conservation law is a fundamental. These are the big fundamentals to me. Now, finally, you have the reference sheet. The reference sheet and sometimes people refer to it as the formula sheet. I don't like that because kids want to know what's the formula for doing this problem. And there is no magic formula. There are a bunch of equations on there that can help us do problems. But the reference sheet is a fundamental. When you're doing a problem and you have to cite some basic physics, go to one of these, Newton's laws, work energy, conservation laws, or the reference sheet for help. So then you have to understand how to answer the questions in AP Physics 1. My suggestion, read the problem. Read the problem. Understand what the problem is asking you to do. You should probably spend more time reading the problem than it takes to answer. And because quite honestly, that's the way it should work. The question is very specific as to what it wants you to do. Read the problem, read the question, understand what it's asking, do it. I don't want to say it's that simple, but really it is. When you do the problem, think about it in terms of force, energy, and momentum. What's going on with this scenario? Is it a force problem? Is it an energy problem? Or is it a momentum problem? This is how I kind of present all my information in the class through these three filters. Is there a system in the problem? Is it just the object? Is it the object in the earth? You got to be very careful. This idea of system can be really quite tricky. And so that takes a little bit of time and practice. You have to know the vocabulary. Physics has its own language. If you don't understand the vocabulary, you're talking gibberish. The difference between acceleration and velocity, big, important, critical thing to know. That's just a simple example. You have to practice continuously. Practice. I tell the kids from day one, 20 minutes every night. Just give me 20 minutes. Look over your notes, do a problem or two. If you do that, you will never study for a test. And some kids do it, and they're doing well. And now it's December, and kids are starting to realize, oh, they're playing catch up basically. You've got to practically continue. Practice does not make perfect. Practice makes permanent. So when you practice these problems, you have to practice doing them correctly. And I go through a lot of that type of problem-solving analysis with my classes. They just want to plug numbers into a calculator thinking, oh, I'll do this differently on the test. But they don't. You have to practice like you mean it. It's no different than practicing for football or soccer or lacrosse or basketball. You've got to practice right. Okay, a couple other things as part of my introduction. I mentioned this before, you have to know algebra. You have to be able to properly rearrange the equation and not do plug and chug, because most of the problems are rearranging equations and not plug and chug. A lot of kids think they're good at algebra. They're simply not. I tell my students, if you write down a number, you have to write down the appropriate unit. Because basically, I don't want them to write down numbers until the very end. I don't want them to plug and chug. The better you understand the units, the more you use them, the better you understand them, the better this whole thing makes sense. Not a big fan of significant figures. I don't require them in my class. I know chemistry teachers do, and I fully understand why they do. Significant figures typically just aren't a big role in physics, definitely not in the AP Physics world, so I'm not too concerned about them. Vectors and scalars are part of the terminology. You have to know the difference, and the difference is more than scalars have magnitude, vectors have magnitude and direction. You have to understand what that direction means. Basically, you have to realize and know that vector components are independent of each other. And as you go through, that will make more sense. But this right here, the vector components idea, is pretty darn important. Okay, so let me just map out real quick. This is how I go through AP Physics 1, and this is how I'm going to be presenting some of these videos in this order. These are the units I have. My first unit is Introduction. I basically just gave it to you. I usually cover that in about 1 day. And then I talk about no net force on a body. And then I talk about we have a single body. It has a net force. I don't care what the forces are. It doesn't matter to me at that point. There is a net force. We look at multiple forces on the body, and then to get our overall net force. We look at two-dimensional motion. We look at systems of bodies, and then I get into rotational motion, and I get into oscillations. These units right here, these 8 units, when I present the information, I present the information in terms of forces, energy, and momentum. And so there's basically 3 sections to each unit. And because I repeatedly talk about forces, energy, and momentum, I always cycle through it. Some people call that the cycling process. Some people call it parallel. I haven't made up my own name for it. The last 2 units, waves and electrostatics and DC circuits, these are kind of standalone units. I don't cycle through forces and energy and momentum. I just kind of go through them. But that's how I break up AP Physics 1. And I cover everything in that order. To give you an idea, I cover everything through Unit 6, first semester. And then Units 7, 8, 9, and 10, I will cover in the first few months of second semester. Gives me time to do a review. Just keep in mind, Galaxy Quest, Captain Jason Nesmith, never give up, never surrender. You got to keep working at it. If you don't get a problem right, try it again. If you don't get a problem right, take your work to the teacher and ask them, what am I doing wrong? But you got to show them the work. You got to keep at it. I'm not going to say that this course is particularly easy, but it's not as hard as you want to make it to be. You actually know more than you think you know. You just don't know you know it. And so I find a lot of my time is spent explaining to kids why they already know it. And then they have to be able to communicate that back in a proper way. So that in and of itself is pretty important. So that's all I have for Unit 1. We finished the first of 10 units. I'm not 10% done, unfortunately. So just want to give you that little quick introduction on AP Physics 1. And then hopefully in the next week or so, I'll be able to get the next unit posted. That is no net force. That's also a short unit. Thanks for checking in. Good luck.